Let's explore message passing, a fundamental communication mechanism between processes in operating systems. It enables processes to exchange information and coordinate their actions. In the diagram, observe Process 1 and Process 2 interacting through the operating system. A message is sent from Process 1 to Process 2, facilitated by the underlying operating system. Message passing is a mechanism that allows processes to communicate and synchronize their actions. Unlike shared memory, processes communicate with each other without resorting to shared variables. This is particularly useful in distributed environments, where processes may reside on different computers. Consider two processes, Process A and Process B. They communicate through a message channel, facilitated by the operating system. Process A uses a send operation to transmit a message, while Process B uses a receive operation to obtain the message. The two key operations in message passing are send and receive. The send operation sends a message to a destination process. For example, send destination message. An example would be send process B hello. The receive operation receives a message from a source process. For example, receive source message. An example would be receive process A and message. Communication links in message passing have several key characteristics. These include direct or indirect communication, symmetric or asymmetric links, automatic or explicit buffering, send by copy or send by reference, fixed or variable message size, and unidirectional or bidirectional communication. With direct communication, Process 1 communicates directly with Process 2 through a direct link. With indirect communication, Process 1 and Process 2 communicate through a shared mailbox. Communication can be unidirectional, where messages flow in one direction, or bidirectional, where messages flow in both directions. In direct communication, processes must explicitly name the recipient or sender. A link is automatically established between the communicating processes. This link is associated with exactly one pair of processes, and each pair of processes has exactly one link between them. In terms of implementation, the sender explicitly names the recipient using the send operation, specifying the destination process and the message. The receiver explicitly names the sender using the receive operation, specifying the source process and the message. Consider Process A sending a message to Process B. Process A uses send B message, while Process B uses receive A and message. In indirect communication, messages are sent to and received from mailboxes or ports. Each mailbox has a unique identifier, and processes can communicate only if they share a mailbox. Key operations include create, send, receive, and delete. The mailbox can be owned either by the operating system or by a specific process. Process 1 sends a message to Mailbox A, and Process 2 receives the message from Mailbox A. Similarly, Process 3 sends a message to Mailbox B, and Process 4 receives the message from Mailbox B. Operations include send A message and receive A message, as well as send B message and receive B message. Synchronization in message passing can be either blocking, also known as synchronous, or non-blocking, also known as asynchronous. Blocking send means the sender is blocked until the message is received. Blocking receive means the receiver is blocked until a message is available. Non-blocking send means the sender continues execution immediately after sending the message. Non-blocking receive means the receiver either gets a message or a null value if no message is available. For blocking, Process 1 sends a message and is blocked until Process 2 receives the message. For non-blocking, Process 1 sends a message and continues execution without waiting for Process 2. Buffering in message passing can be categorized into three types: zero capacity, bounded capacity, and unbounded capacity. Zero capacity means no messages are queued, and the sender must wait for the receiver to be ready. This is known as rendezvous. Bounded capacity means the queue has a finite length n, and the sender must wait if the queue is full. Unbounded capacity means the queue has potentially infinite length, and the sender never waits. For zero capacity, both process 1 and process 2 synchronize at the same time for the message transfer. For bounded capacity, a buffer stores a finite number of messages. For unbounded capacity, a buffer can store virtually unlimited messages. Let's explore some real-world examples of message passing and summarize key takeaways. One example is the POSIX message queues, a standard Unix or Linux inter-process communication mechanism that provides persistent message passing. Code shows message queue open/myqueue and message queue send, message queue buffer size 0. Another example is microservices communication, where services communicate via message brokers like RabbitMQ, Kafka, and Redis. Code shows channel basic publish exchange routing key null message get bytes. Key takeaways include that message passing provides process isolation and supports both local and distributed systems. Also, synchronization can be blocking or non-blocking, and buffering affects performance and coupling. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.